Functional groups. One is the carboxyl group that is found on the carbon, one in this area, and the other is the amino group that is found in this area. The amino group will have what we call a basic character, and the carboxyl group will have an acidic character. If we analyze the structure of the carboxyl group, what we see is that at the end where the O group is, the hydroxide group, the difference in electronegativity makes oxygen attract electrons more, generating a negative dipole, and therefore in hydrogen a positive dipole is generated. On the other hand, in the amino group, nitrogen has two paired electrons without sharing, which are related to protons, that is, to H+ ions. What happens in this situation? What is going to happen is that the hydrogenion from this area, that positively charged hydrogen atom with positive charge density, is going to be attracted by those paired electrons. What happens when it is attracted by those paired electrons? What is called is formed, a dipolar ion. Then the hydrogen leaves the oxygen and joins the nitrogen, which has separated electrons. The structure would be like this. The carboxylate anon that is formed will now have a totally negative charge. It will not be a charge density of the oxygen, but it will be a positive negative charge because it lost the hydrogenion, and in the second carbon there will be the nitrogen with the two hydrogens that it had plus one more that joined those Desiree electrons and that carried with it its positive charge. In synthesis we are left with a dipolar ion because it will have two poles within the same structure, where one end is the negative end of the carboxylate ion and the other end will be the positive one that will be in the ammonium ion. This ion thus formed is called a dipolar ion, or also